Hey everyone, this is Unit 7 in Algebra 2. We're talking about rational functions, rational expressions. Um, so we previously looked at just some of the properties of rational functions, right? Kind of what they look like, some of the features of them. We've talked about some of the math behind them, how to add them, subtract them, multiply them, and divide them. Today we're going to talk about how to solve rational equations. So remember that rational, right? Its base word is ratio. So we're talking about fractions. And so we're going to look at how to solve equations involving fractions. And those fractions are going to have variables down in the denominator of that fraction. Okay, so we're going to be looking at common denominators, right? And least common multiples. And so we'll talk a little bit about that as well. Okay, so this is just kind of an algebra 1, level equation here. This is very typical of a problem we might see and have to solve. We have some fractions in this, and I know that a lot of people, they don't like working with fractions, but we need to find a methodology, right, a practice that we can go through to help us deal with these fractions and to eliminate them and to just not get worried about them. So what we're going to do here is we're just simply going to try to get rid of the fractions in this equation. All right, so the way that we do this, right, this number down here, this 7 and this 3 means divided by. So we have something that's divided by 7 and we have something that's divided by 3, and this 4 is technically divided by 1. What we're looking for is a way to get rid of that. Okay, so how do we undo division? Well, we undo it with multiplication. Okay, so as long as we multiply everything in the equation by something, we don't change the equality of that, right? We don't change the nature of that equation. So what we're looking for is something that we can multiply everything by that will get rid of this divided by 7 on the one fraction and get rid of this divided by 3 on the other fraction. And so what we're looking for is what's called the least common multiple. And so what we're going to do is we're going to look at these two numbers, and we're going to look at the factors of these two numbers, and then find another number that has all of those factors in it. Okay, and that's called the least common multiple. So 7 is prime. So the only factors there are 1 and 7. 3 is also prime, so the only factors of 3 are 1 and 3. And then we can talk about this 1 here, but it doesn't really matter because 1 is a factor of everything. All right, so we're looking for something that has factors of 3 and 7. And so the easy way to do that is just to multiply these, right? I need a 7 and I need a 3. And I need them multiplied together. So I'm going to use 21. So the way that I'm going to do this is I'm just going to multiply each one of these terms by 21. That's kind of fat there. So I'm just going to multiply each one of these by 21. So I'm going to say 21 times this, 21 times this, and 21 times this. Okay? Now, what happens here? Well, I can go ahead and multiply 6 times 21 and what's 126 or something. But what I really want to do is I'm trying to get rid of this 7. And so this 21 is really 3 times 7, right? We chose it to be that way. And this 7 and this 7 will cancel out. 7 divided by 7 gives me 1. And so what I'm really left with here is just 3 times 6. So I get 18x. No denominator, or denominator of 1. Likewise here, this 21 is really, 7 times 3. And so this 3 and this 3 will cancel out. And so what I'm really left with here is 7x. So this is equal to 7x. And then the 21 times 4 is simply, 84. Okay, so now I have an equation. I don't have a rational expression anymore, right? I don't have a rational equation anymore. I just have a regular old, this just happens to be a linear equation, and it's pretty simple to solve. So now I just go through my regular problem solving thing. I'm going to subtract 7x from both sides, get the variables, variable terms by themselves. And so I get 11x is equal to 84. And then I want to get the variable now all by itself. So I'm going to divide by 11. So I get 11 times x. I'm going to undo that multiplication with division. And so I get x is equal to 84 over 11. Okay. Now, this is not the only way to solve this type of equation. I could have just left these. I could have found a common denominator. I could have combine those, with that common denominator. But at some point, right, I'm going to have to get rid of that denominator, right? To get x all by itself, I'm going to have to get rid of that denominator. So at some point, I'm going to multiply. And so I just simply chose to do that first. I did that multiplication step first just to make the rest of that problem a little bit easier. This is the general approach that we're going to take when we have more complex rational expressions, rational equations, where we have variables in the denominator of the fraction. So let's take a look at one of those. All right, so here we have a rational equation here. Notice I've got variables down in the denominator now, but it's a similar sort of a thing. Right? I've got stuff in the denominator. I want to get rid of that. This means divided by. So what I'm going to do to get rid of that division is multiply. What do I need to multiply? Well, I need to multiply something that has an x as a factor and that has a 4 as a factor. If I look at 4x here, right, the factors of that are 4 and x. I could also say it's 2 and 2 and x, right? But if I just used a 2 and not a 4, it wouldn't be enough to cancel out that 4. So I need to have 2 of those 2's to cancel that out. So I need a 4. And then again, my denominator here is 1 on this 3 is 1. So I can just kind of ignore that. It just doesn't play a role in this. So I need something that has an x in it and that has a 4 in it. And so 4x is my least common multiple. 4x is my least common multiple. So do the same thing. I'm just going to multiply each one of these times 4x. And just to make this clear, it's not 4x minus 9, it's 4x times negative 9. And then this is 4x times 11 and 4x times negative 3. Okay, so just kind of keep that in mind that we're multiplying that negative 3 times 4x. So when I go through here, these x's will cancel out. Okay, x is actually hard to cross out an x. So I get 4 times negative 9, that's negative 36. This 4x and this 4x will just simply cancel. And so I've just got 11. So this is equals 11. And then I've got negative 3 times 4x. That's going to be negative 12x. Okay, so again, all my variables in the denominator, my denominators are all gone, and now this is just a regular old linear equation that I can solve. So I'll go ahead and subtract 11 from both sides. And so negative 47 is equal to negative 12x. I need to get the x all by itself, so I'm going to divide by the coefficient here, divide by negative 12. Divide by negative 12, negative divided by negative is positive, so I'm going to end up with 47 over 12. Now, I always want to just kind of do a double check here and make sure that I can't simplify this at all. If I chose my least common multiple properly, there's a pretty good chance that I won't have to reduce this, but I always want to double check, and 47 I believe is prime, so there's nothing that those two have in common. All right, so there's my answer. Let's take a look at another example. This one's a little more complex. So instead of just having a variable in the denominator, we actually have a binomial in the denominator. And remember that I have to treat each one of these things as has a unit here, right? So that denominator here is x plus 3. This denominator here is x plus 1. This denominator here is 2. So again, I'm looking for that least common multiple, the thing that I can multiply by to cancel out an x plus 1 and a 2 and a 3x plus 3. So I'm going to see if I can factor these. X plus 1 can't be factored. All right, this is a prime number here, and there's no common factors there. 2 is also, that's a prime number. That can't be factored. But if I look at this, 3x plus 3, that has a common factor in it. Okay, so there's a GCF in there, right? Greatest common factor. 3 goes into 3x, and 3 goes into 3. And so I can rewrite this as 3 times x plus 1. Okay, so now if I look at my factors, I have an x plus 1, I have a 2, and I have a 3, and I have another x plus 1 here, but since I've already got that x plus 1 here, I don't need another one. All right, so I've got x plus 1 times 2 times 3. So my least common multiple, right, my least common multiple is going to be 2 times 3 times x plus 1. Or we could also write that as 6 times x plus 1. I'm going to leave it factored out like that. And what I'm going to do is I'm going to multiply each one of these terms by that. So I'm going to go ahead and write this out. So I have 7 times 2 times 3 times x plus 1, and I'm going to write that out a little bit differently just to make it more clear. So I have 7 times 2 times 3 times x plus 1 over my least common multiple. So this is going to be 2 times 3 times x plus 1. Oh, that's actually wrong. I did that wrong. X plus 1. So I'm multiplying this by that. So this variable, I'm sorry, this stays the same. This is x plus 1. Sorry about that. Sorry about the confusion there. All right, so I'm taking 7 over x plus 1 and multiplying it by 2 times 3 times x plus 1. I'm multiplying it by that least common multiple. And then I've got minus 1 over 2 times this least common multiple, 2 times 3 times x plus 1. Again, be clear about how I'm writing this. Okay, so I get negative 1 times that stuff, and then that's going to equal 8 times the least common multiple, 2 times 3 times x plus 1. And that's 8 over 3 times x plus 1. And I'm going to write it in that factored form. All right. Okay, so all I've done here is I've just taken each one of these and multiplied it by that least common multiple. Now, let's see what we can cancel out. So this x plus 1 and this x plus 1 will cancel out. And so I'm left with 7 times 2 times 3. That's 7 times 6. That's 6 times 7 is 42. And then here, the 2's will cancel out. And so I've got minus, and it's 1 times 3x plus 3. So that's really negative, right? And I'm going to multiply those out, 3x plus 3. Okay, now we want to be really careful here. This is an easy place to make a mistake. I want to make sure I capture that subtraction there. And then just to make this easier to write out, I just went ahead and distributed that 3. So it's minus, and then that whole thing, 3x plus 3. The 2's go away, and so I don't have a fraction there anymore. And then on this side, I get the 3 cancels, I have the x plus 1 canceled, and so I just have 8 times 2 is going to be 16. Okay, and so now I've turned this back, into just a regular old equation, and I can go ahead and solve that. So this got a little bit messy right through here, right? And it's simply, there's just a lot to write. So we're taking this least common multiple and we're multiplying it by each one of these fractions, right? And we're simplifying and rewriting. And so if I continue on here, this is going to be 42 minus 3x minus 3 is equal to 16. And then 42 minus 3 is 39. Minus 3x is equal to 16. And I'm going to clean this up a little bit. Make this a little bit smaller so that I can kind of fit this in here. And I'm going to come up here. So I'm going to come up here. My phone's not writing. Boy, technology, I'm having a hard time. All right, so I'm going to subtract 39 from both sides. Minus 39. Minus 39. And so up here, I've got negative 3x is equal to 16 minus 39, that's going to be negative 23. And I'll divide by that coefficient there. And so negative divided by negative is positive, and so I get x is 23 over 3. Okay, and I'll just leave my answer like that. 23 is a prime number, 3 is a prime number. Those can't be simplified. So, so there's our answer there. All right, one more example. We'll see if my software can make it through this. So here we have a fairly complex, rational equation. So again, I'm going to look at each one of these things, right? That's a factor. This is a factor. Each one of these denominators, right? We're looking to factor them. And then this is one thing, okay? Now, this x minus 1, I can't factor that. X plus 3, I can't factor that. But I should be able to, I hopefully can be able to factor this. And so if I factor this down, okay, I'm looking for the factors that multiply to give me negative 3, but that add up to give me 2. And those numbers are going to be 3 and negative 1. Okay, so 3 times negative 1 gives me negative 3, and 3 plus negative 1 gives me positive 2. So here I have x plus 3. And x minus 1. Okay, so I'm gonna ignore that, and I'm gonna just keep it in this form. Now, this actually worked out really nicely because look at my least common multiple. I need an x minus 1, and I have that here. And I need an x plus 3, and I have that here. So this is going to be my least common multiple. This is my least common multiple. So I'm going to multiply everything by this, x plus 3. Times x minus 1. And so if I do that here, so again, I'm going to write this out. So I got x plus 3 times x minus 1 times that numerator, x plus 1, right, over x minus 1. And I put brackets around all this stuff. It just helps remind me that those are, individual things, right? Those are individual factors, and I want to treat that as a single object. Now I have negative 1 times my least common multiple, x plus 3, x minus 1, and over x plus 3. And then oops, this is going to be a plus, x plus 3, plus, and then we have 8 times that least common multiple. So x plus 3, x plus 1, sorry, x minus 1. Now, I'm writing all this out. A lot of this, you can kind of look ahead and see what's going to happen here. But I'm writing it all out here just so that we're very clear, like this is the process that we're going through. Yeah, so now we're going to look for things to cancel, and so I end up with x minus 1 will cancel out, and so here I have x plus 3 and x plus 1. And that's going to equal, and then here my negatives will cancel, or my x plus 3s will cancel out. And so I have negative 1 times x minus 1. Okay, so negative 1 times x minus 1. That's going to be negative x plus 1. So I'm just going to go ahead and write that out. Negative x plus 1. And then right here, both of these will cancel out. And so I'll just be left with plus 8. All right, so let's keep going here. So now to solve this, right, I need to go ahead and expand this out. So I need to multiply these two together. So this is going to give me x squared, and then I've got 3x plus 1x is going to give me 4x plus 3 is equal to negative x plus 9. Okay, now here I have a binomial, or not a binomial, but a quadratic trinomial, right? So to solve that, what I'm going to do is I'm just going to make it equal to 0. And so I'm going to scroll down here a little bit. And so I'm going to go ahead and add x to both sides, and I'm going to subtract 9 from both sides. So I'm going to add x to both sides and subtract 9 from both sides. And so here I have x squared plus 5x minus 6 is equal to 0. Okay, now to solve this, right, remember that this represents a parabola, right? And so what we're really looking for are the x-intercepts. Okay, so I'm looking for where this y value is equal to 0. So I'm looking for the x values that give me 0. So I'm looking for the x-intercept. So the best way to do this, or the kind of the quickest way, is if I can factor this, that will quickly tell me my x-intercept. So I'm going to try to factor this by look at the factors of negative 6 that add up to positive 5. So I think that's going to be positive 6 and negative 1. And so I'm going to get x plus 6 I'm going to type this out because this is let's see what happened here. Where'd it go? Software. Okay, I'm going to type this out. And there my software crashed. Okay, so we kind of missed the ending there, but hopefully you see that. You get x plus 6 times x minus 1 equals 0, and then you can go ahead and set each one of those factors to get to 0, and so you get x is equal to negative 6, or x is equal to positive 1. All right. Apologize for the end of that. That's not the way I wanted to end that video, but hopefully that will kind of get you going in that in the process of doing that assignment. And so take a look at those assignment questions and let me know what questions you have.